Okay, I think we'll get started. It's 4:30. So the structure, just a little background before I introduce myself. The structure is we will be in small groups, and so it looks like people have not. We're going to do 3 small groups. So if you could seat yourself in one of these circles over here, and up here.
We want 3 groups.
3 groups. So just kind of spread yourselves out among these little circles.
And then if more people come in, we'll just explode everything and move you around again.
So yeah, we could use some people up here and then in that group.
We can expand circles.
Yeah, we can have another circle up here because we have 3 groups.
Actually, you guys in the middle there, you want to move to the end so that you don't interfere with each other sound-wise? Should be nice.
Yep.
Get more animated. Yeah. We need a couple of people up here.
Okay.
They're all lonely, they only have 3. Help them out.
All right, I'm going to introduce myself, and the rest of the panel will introduce themselves, and then we'll get right into it. So I'm Carly Easton. I'm from University of Arkansas.
Hi, I'm Andrew Meltzer from GW in DC.
Hey all, I'm Mike Alib. I'm Vice Chair of Research at Rush in Chicago.
I'm Peter Ho. I'm at the Brigham Women's Hospital.
Dan Mayer, I'm retired from Albany Medical College, and here I'm still here.
Nice to meet you all. Martin Wegman, Orange Park Medical Center, also with ASAP.
So this is designed to be very interactive, but we are going to start with a little bit of background, and so I'll hand it over to Andrew.
Thank you. Can I use the regular mic? I'll use this one. Hello. Thank you guys for coming. This is great. I know it's late in the day, but it's great to have a big crowd, and hopefully this will be a good session. So this is a fun talk. We've done this for the last couple of years, and what's nice about this talk is that, chart reviews are a real common study that we do. Usually you don't need funding for it. It's one of the things you do with med students a lot, with residents. And it's not hard to do it really well. You can do this as well as the best people in the world, or you could spend months and months going through charts and really come up with something that's really not going to be much of a product. So if you learn the methods well, and you can learn it in the next 30 to 40 minutes, you'll be as good as the best people in the world, and you'll have a great paper at the end. So what's nice about it is that it is not too time consuming, and then for many people, it's your first exposure to research. So I know when I first started, when I'd have med students or residents, I often wasted a lot of people's time. I feel like that first summer I had a couple of med students, and they went through charts, probably spent weeks and weeks, and at the end we had this product that really wasn't that publishable, and I remember feeling a little bad about that. But I think now I'm able to structure and do the right methodology to really help people get a good publication. So for emergency medicine, it's about 25% of all of our publications. And again, what's nice about this is that the data is already collected. The downside is that EHRs are really not made for research, and EHRs are really made for communication and for sort of medical legal protection. And let's talk about the studies. So there's basically 3 studies you need to know, and that's it. If you know these 3 studies, you basically, again, are as good as anybody. So the first one came out in 1996. This study has thousands of publications. Whenever you write a chart review, people tend to cite this. It's this Gilbert and Lowenstein study that basically says chart reviews, where are the methods? So what they did in this study, and we should have, do we have copies of this? I'm not sure if we do, but yeah, take a look at this. Just remember Gilbert and Lowenstein, it's pretty easy to look up. We do have a QR code at the end, so you can get all the references at the end on the QR code, so you don't need to take pictures. Basically what they did is they went through a whole bunch of ER chart review studies, and they tried to identify the high quality characteristics. And what they came up with were 8 characteristics that they used. This is the Gilbert Lowenstein study, and these are what I think everybody uses today. These are the basic 8 characteristics. And when you write your methods, you're going to have to address each of these 8. And if you didn't do one, you're going to have to use that as a limitation and just say, I wasn't able to do that. This is what I wasn't able to do. This is the reason. And as long as people know that you at least know the best possible methods, I think you can still get your paper published. But going into an advance, if you can do it as good as possible to reduce bias, that's really the best possible way. So those 8 things that you see here are training. So you can't just sort of send your med student out and say, here are the charts, you go figure it out. You really have to sort of train them of where to look. Think about how complicated the chart can be. If you're looking up a pulse ox, is it the first pulse ox, the triage pulse ox, is it the first nurse pulse ox? Where do you look? How do you define that? And this gets even more important when you're doing these things automated. So when you start getting automated downloads from EHR, really defining your data elements is really important. Case selection. So just like you would do with an RCT where you have a consort diagram, you're going to have a similar thing for a randomized control. You're going to have a way that you're going to screen for patients. Usually it's an ICD-10 code or a CPT code, so you're going to get a large selection. You're going to screen out a certain number of patients. Maybe you only want people 18 and over. Maybe you only want people who are ER-based, people who didn't die or things like that. So you'll go from 1,000 to 600 with your case selection. Definition of variables. So you really got to be really careful about doing this early and doing it before you do your study. This is really hard to do sort of in the abstract. Usually I'll make a best guess and then I'll go through a couple charts myself and see if I really defined them appropriately. Because sometimes you'll find that you really didn't define it the way you meant to. And even nowadays, things like gender can sometimes be defined lots of different ways, and sex and those things. And you might write it one way and then realize, wait, I really need to define this a little bit differently, and so on. Abstraction forms, common abstraction forms. If you just use an Excel sheet, that can be fine. You can also use things like REDCap, which we often use. But having a definitive form as opposed to anything like free text or Microsoft, you don't want to just be doing a unstructured abstraction form. Regular meetings, you can't sort of leave people on their own and meet them once in beginning of the summer, once at the end of the summer, and just sort of hope it all works out. It's not going to work out that well. You got to have people who are looking after the abstractors, staying on top of them. I mean, personally, I think you should meet them at least once a week and see how things are going. And ideally, you're going to have 2 of them, more than one, doing at least some of the charts. So that's number 8. That's testing of inter-rater reliability. So for me, I usually do 10% to have at least 2 people do both the charts. Then I go back to it and see how much they match up. And for some elements, that's really hard, like location of abdominal pain in your HPI. That might be a real hard data element because it's not really defined in a structured way. But for some things, it should be pretty easy. Like if you're getting heart rate and triage, that should really be the same across both of them. Number 7, blinding. This is the one that I usually don't do just because it's really hard to get med students and residents to do a project and really not tell them what they're doing and why they're doing it. So I usually write that as a limitation that I didn't fully blind people. If I can, I'll sort of keep it vague or tell them they're doing it for another reason. But blinding is one that at least you know that, okay, this is the best way to reduce bias if your abstractors were blinded, but you're not always going to do that. I think it's a little more important with your RCTs when you're doing follow-up to get primary outcomes. But for this, I think it's okay if you mention that you didn't do it, but if you can do it, if you have especially paid research assistants or people that might do your work without knowing exactly the scientific reasons for it, then blinding is ideal. So this is the first study. This is the Gilbert and Lowenstein study, 8 characteristics, 1996. This was added to in 2005 by Worcester and said, okay, if 8 is good, came up with 4 more elements. And these are the 4 elements here. So if you want to cite this and really go for the gold here, medical record identified, how did you get into the database, what is your sampling method, missing data plan. This is where it can start to get a little bit complicated. What do you do when certain elements are missing? There's different statistical ways to deal with missing data. And then finally, just mentioning your IRB. I think this is pretty obvious that we're going to have an IRB if we're going through chart review, but if you're going through a chart, this is human subjects research because you have interaction with data elements that are identifiable. So therefore, because it's human subjects research, you need to get IRB approval. Usually it's the low risk type study or exempt study, but it's still something you need to get approved for. And then finally, this was the second study, so this is the Worcester study. First study was the Gilbert and Sullivan. I said Gilbert and Lowenstein. I always say Gilbert and Sullivan, like that was a musical group. Yeah, but anyway, moving on. I always say that in my head. And then Worcester, 2005. And then those are the 12 elements. And then Kaji, Amy Kaji, I think I've seen at this conference walking around, 2014, added a little bit more to this. This is your 3rd study, only 3 studies you need to know about chart reviews, basically suggesting pitfalls and solutions. about how to reduce bias in the chart review. So potential pitfalls, maybe you shouldn't have done a chart review. Maybe that's not a good choice. Maybe you have conflict of interests. Maybe your sample is underrepresentative. I think I saw Ryan walk in. We were looking about doing a chart review on septic joint. We kept sending IT or the different ICD-10 codes for septic joint. Kept coming up like 4, 5, 6 patients. Like clearly wasn't enough to do the study that we wanted. So then we go back and we say, okay, let's do a CPT code for arthrocentesis. Maybe we can find them that way. Just trying to figure out where your coding is going wrong. And all this stuff you can do as preliminary work to your research. To me, I don't get an IRB approval for those kind of searches. I'm doing that as I tell them this is prelim to research. Give me data. I don't want PHI. I just want to sort of plan ahead. Data conflicts. This happens a lot, especially if you're dealing with computer science type people or doing automated data pulls. Sometimes this can get very complicated of where you're pulling different data within the EHR because sometimes one element can conflict with another, especially if there's serial measurements. The training, again, might not be that great. What's your percent check for reliability? Again, I usually do 10%. I think that seems to be sufficient with most reviewers, although I think Dan would probably reject me for 10%. He's the toughest reviewer I've ever had.
I think that's a reasonable
okay.
number, but it depends, if you have 12 charts.
12 charts, exactly. Then you might want to do all 12.
Then you gotta do them all.
Exactly. Or if you see that there's a lot of problems, then maybe you want to do more just to make sure. Then you want to go a little bit higher.
If you've done your first 10%, if you come up with an inter-rater reliability that's really bad, then you got to go back and look why are these two people coding them so differently, and do another 10 or another 10% of charts.
And that goes back to your training, and then it goes back to your meetings. If you see that there's a big difference there, and then sometimes you might have a third person who serves as a arbiter. Yes.
So I'm in the middle of a retrospective review right now,
Mm-hmm.
and I just did what I would consider to be training, where I have the two RAs do the same charts and then
Mhm.
compare them.
Sounds great.
And discuss them. But I assume that that is going to be different than doing a check for reliability.
Yes. So training, what you did is great, and I think you put that in your methods, that we had 2 abstractors. They were both trained. We had a session with training, some way to describe that. Or you could just say, we followed the guidelines in these journals and just cite that. But then check for reliability, what you'll do is you'll literally look at the elements, and most people will use something like a Kappa-Cohen statistic or something, pretty simple like that. Or you can sort of just look through it and sort of eyeball what you're doing, come up with the sort of basic stats about agreement. Yes, Dan.
I just wanted to clarify your question. So the group that you have right now, you have them both, the 2 RAs together looking at the same charts?
No, they would look at the charts independently from one
Independently.
another, and then we compare them
Okay.
to see.
So that's the inter-rater reliability.
But I'm doing that specifically as training because we're just starting off.
So
And
where
so
does
those-
training and measurement?
Right, that's my question.
Is there a sharp line?
Where is the
between them?
line between that? Because my plan was that we do a certain number of charts that we're just considering to be training charts. And then we're gonna start on the rest of it as like the real thing. And then for the real thing, I would assume that I need to get the inter-rater reliability stats for the real thing.
Yes, that makes perfect sense, and that's a reasonable way to do it. Probably your initial training charts would be outside of the time window, or some other reason that you would be doing that, so that you'd get your RAs used to what they're looking at and why they're looking at it, and then you would have a separate session where they would each code a certain number of charts, and that would be your inter-rater reliability.
And what you're describing also is so important also in terms of modifying your case report forms, because you'll see that when there's areas where there's huge differences, especially early, you'll say, wait, maybe I can ask this question a little bit differently, a little more precisely, and then I go back to it. So I think it's incredibly important to have those early sort of just trial runs as you modify your case report forms before you just like send them into like autopilot and say, come back in a week. So yeah, I think that's so important to do what you did, and then just, it's sort of part of training, but it's also part of just sort of piloting your CRFs, which I think is a bullet point right here. So we never put a CRF into like full use until we've done a few cases, whether it's a prospective observational trial, an RCT, or anything, until we've gone through with a few participants just to make sure that like everything's working out well. And even for this. So, I mean, all that sort of goes into sort of the idea of methods of like reducing bias, making sure that the data that is being collected is true data and matches up as close as possible to the actual patient. So I think what we'll do is, the plan is to then break up into groups and actually look at some chart reviews. And then Dr. Meyer is going to pass out some checklists. And Dr. Easton, oh wait, you're going to go through them first. Sorry. We're going to go right on to, okay. Dr. Easton's going to take over with a couple slides.
Okay. So what we're going to do now is each group is going to have one paper that may or may not be so good in terms of chart review. And we're going to just look at all of these criteria we just talked about. And can we find those? And keep in mind, these are published papers. And so they did make it past peer review. But they do have some flaws. And so can we figure out what are the themes and where are they? What are they missing? And then we're going to come back in a few minutes. We'll come back in maybe 20 minutes and then talk about it as a big group, because there are definitely things that come frequently in different papers as the same flaw over and over and over.
So pick somebody in your group to be the reporter. We'll report out at the end which of the elements were present and which weren't.
Okay, so we have about 10 minutes left, and I'm hearing really great discussion, but it's probably time to start going over these papers. So if everyone, we're going to kind of discuss each paper in a little bit of detail. Apologies if any of the authors are in the audience. Okay, who has the appendicitis paper? Okay, so I'm going to hand off to this group, and they're going to just talk about this paper and kind of what was there and what wasn't there.
Hi, everyone. We had a paper on determining whether symptom duration, C-reactive protein, WBC count, and absolute neutrophil count were helpful in diagnosing pediatric appendicitis. These. And I have my answers. Okay. These investigators looked at a convenient sample of consecutive patients who had an MRI for potential appendicitis, and then looked at laboratory values to see whether the laboratory values were predictive of the ultimate diagnosis. So in the methods section, they did not describe any abstractor training. They did describe inclusion criteria, which was basically any pediatric patient who showed up and got an MRI for suspected appendicitis, but did not describe any exclusion criteria. They did define variables, although they did not address the bias that was inherent in some of the subjective aspects of at least their major variable. They did not mention any abstraction forms, and they did not mention any description of how they monitored performance of the chart abstractors. They were clear that no one was blinded, so they were specific about that. They did not describe or mention any kind of inter-rater reliability being tested or anything related to inter-rater reliability. They did not even describe who was doing the abstraction, how many people they were, or anything about the chart abstractors whatsoever. They simply stated data was abstracted. They did specify that the data was obtained from the electronic medical record, but they did not give any description of the hospital system or hospital type in which it took place. So we don't know whether this was a community hospital, an academic center, a children's hospital, all of which are relevant things. They did describe the sampling method. It was all consecutive patients within the study period. They did not describe anything related to missing data, and if you read the results, they had quite a bit of missing data and did not mention how they dealt with that. But they did specify that it was approved by the Institutional Review Board.
Great. So this would get maybe, there's a lot of things missing here. So again, these were all published papers. So some things to note, and let's go over to this article.
Hello, Ian Brown, Stanford. Our paper was around the impact of fasting guidelines on orthopedic procedural sedation in a pediatric emergency department. And let's go through the list. So what was the abstractors training? It was not mentioned at all in this paper. Case selection criteria were the inclusion and exclusion criteria for the case defined. So we do know that this was that it was a consecutive patient study. And so supposedly it was all patients. It could have been far more clear in the paper who they were looking at. Variable definitions. They gave again some variable definitions. Some were kind of obvious: start time, end times, like in order to determine length of stay. They were very nice, and they sent us to a reference for how they defined adverse events and procedural sedations, which we really appreciated. Abstraction form was not discussed. Performance monitored was not discussed. Whether the people who were abstracting were blind to the hypothesis was not discussed at all. It was inner observer reliability was not mentioned at all in this paper. Medical records identified was not delved into in this paper. Sampling method, it was, like I said, it was consecutive, so that was adequate. Missing data plan, the paper said if they were missing data, they excluded the patient. It was about 10% of the patient population. We had some concerns, like what it meant to actually be missing data, if there were whether it was just one of the primary outcomes, or if they're missing minor things like race or gender, how that would affect, and whether those were excluded patients. But they at least identified and spoke a little bit about missing data. And it did, for IRB approval, it did say it was IRB approved. It didn't get to whether it was an excluded study or what kind of an IRB it was, but we appreciate the fact that it was IRB approved.
Thank you. Great. So you can see some themes emerging on things that are frequently missing. Let's go to the last paper.
Hi, Cindy Bitter, St. Louis University. In terms of our checklist, there was a very, very vague mention in a completely different section that the abstractor had received training in appropriate methods for chart collection. They sort of did their case selection criteria, but it was complicated. And then they went back, and it's unclear if they data dredged and excluded some people after realizing that it wasn't contributing to their predictive model. A lot of their variables were pretty basic labs, so there was some variables that didn't really need variable definition. They did not mention using abstraction forms. There was a vague mention that like one person reviewed them and then the corresponding author reviewed it. So it was sort of monitored, but they didn't mention anything about reliability because technically everything was just abstracted by one person. It's not mentioned that they're blinded to the hypothesis. The IRR and testing, again, was not calculated at all. They did say that they used their data collection, whatever chart system for their hospital, but don't describe much else about it. Their sampling method, again, was also rather convoluted because it was a population who had been seen for dizziness, had an MRI, and had seen a consultant, but they don't really describe like how they got, like what they searched first to try to figure out. Like, did they look at everyone who had an MRI and then go see what the consultant said versus finding everybody with dizziness? They do mention that one patient was excluded because they didn't have labs, but they don't say anything else about a plan for handling missing data, and they do say that they were authorized by the IRB.
Awesome, thank you. So what are the common themes here? Get out of the way. So we have, decent description of IRB and maybe their variables and how they did their statistics. But I would say all three papers were missing details about who did the abstraction, how they trained them, whether or not there was any inter-rater reliability measurement performed, and a lot of, several other details that were kind of maybe in some papers, but not others. And so that's a common thing that is missing in chart review manuscripts. And these are things that are not particularly really that difficult to do, but you have to know to do it early before you start your study. So in your planning process, if you know that you need to have two, abstractors, or at least have someone review 10% of the person who's doing the bulk of the abstracting, you do that early, and then you make your edits and adjustments as you need to if the reliability is poor, before you do 500 chart reviews. And then you have to go back and say, oh, our reliability is really poor. That's not good. We have to redo the whole study. You want to be doing that right up at the front. And so a lot of these things can be done without a lot of time or effort if you know about it ahead of time and you put it into the planning. Okay, I think we're about out of time. Do we have, I will say, we are going to give you some resources and some good, not amazing papers, but better papers that have a little more of an example. No papers are perfect, but have a little more of an example of what you should be doing. And then also the 3 background papers and the electronic version of this checklist so that you can have that for you. And then we'll take any questions. Yes?
I have a question.
Yes.
So the 12 steps here are classic. It's what we need to do for a retrospective chart review. It's what we've done for most of our careers. These days we don't do it like this anymore, right? It's all electronic database records. I'm not hiring, medical students anymore. I'm not hiring medical students anymore. There's no, they don't rely on code, they don't rate reliability because it's all,
It's all.
the red tab from the subject area market. How does this apply to the next 10 years?
Yeah, so that could be its own lecture, but Martin is going to talk a little bit, and I apologize, I forgot to have him do this, but he was going to talk a little bit about big data and how it's a little bit different.
Yeah, no, it's an excellent question. Very, very relevant. And exactly, on target, that you have your EHR, you get a data dump from the EHR. I think there's a few factors to consider, and I talked a little bit about this with this group, but first question is what type of study and what type of inference or conclusion are you trying to make? What's the primary focus of your work? This should dovetail right from your research question. Many of these papers were predictive, what I would call predictive, category of predictive, and that's going to require a different approach, different set of kind of methodologies, and so we can talk about that a little bit. There is 2 other categories that I typically reference. The other one is causal, and causal includes both treatment and its effect on an outcome, which is often interventional in nature. Another causal type of study would be if you're seeking to study what effect an exposure has on some sort of outcome. So causal studies, I'm going to talk about a framework that can be applied in just a moment. But then descriptive studies would be others, those that are solely descriptive, seeking to kind of provide essentially just describe a context, give some clarity about a context, maybe estimate, the proportion of people that have appendicitis, the proportion that are male or female, or those types of things. Those are purely descriptive questions. So often we seek, and there was a great JAMA discussion on this review point recently in the past couple of weeks about the causal intent of our language, and often we are seeking to make causal inferences actually, but we're trying to disguise our ability to do so. We're calling it associations or things like that. But those are causal intent studies. So that's a causal study. So, I think the best framework to apply for a causal study, and I'm sad that, we propose this didactic, but I'm sad it didn't get accepted, is called target trial emulation. And that's a framework that's being increasingly used as kind of the standard approach to performing causal inference work with observational big data sets. And so I encourage you to kind of watch a couple of videos. Miguel Hernan out of Harvard is, the thought leader in this work. Target trial emulation is essentially trying to replicate an RCT with your data. And so you kind of follow through just as you would for an RCT, defining kind of a protocol of who am I going to include, who am I going to exclude, how am I going to define what the intervention is. You do the same thing, but in an observational setting. So highly encourage anybody who's serious about doing any type of causal inference work to read about TTE and kind of start incorporating it into your work. I think there's a related piece, though, is just like the validity of the data, and that's a big concern with EHR data because of it's a secondary use kind of situation, just as it was in manual review. Multiple ways that you can show validity of your data. One is kind of triangulation, essentially, with other data points. So that's highly useful. You can also do manual abstraction on a proportion to kind of confirm from unstructured data elements. Manual being either person or AI, generated kind of manual abstraction to kind of confirm those structured data elements. But yes, absolutely needs to happen that you should validate your core measures and show evidence of that. And then also, and this is somewhat related, but like quality checks, inconsistency checks, logic checks. So a variety of things, like if the timing of your intervention is like, if the timestamp is kind of incorrect because it's like it's occurring before they even arrive to the ED, right? Those are types of things that you also need to do and identify and kind of handle. And I would say the literature, people aren't great about doing that or describing how they handle those situations, but they are common. And so kind of those logic checks are pretty critical. So, I mean, you've heard it time and time again, like 80% of this work is like cleaning and kind of dredging and checking the data and stuff. So unfortunately, that still is the case with EHR data.
I think if anyone wants to write the new Gilbert and Lowenstein for big data, sign up. Some people are helping. We need it. I mean, I think that we all know how bad the chart reviews are, or how the computer, the stuff the computer spits out as to what happened, the ICD-10 codes, and how should you deal with that? I think we need some new guidelines for that.
Yeah, and related to like just pulling, EMR data, if you're not physically going into the chart, I think the iterator thing is, I agree, it's not relevant because you would expect if you pulled the data again, it would be the same, right? Because it's an EMR pull. But you can do probably a more detailed job describing kind of those definitions and how, like, and that may be something you put in an appendix, but it would be like a little more detailed on how you defined X variable, where was it pulled from, and how do you know that it was consistently pulled in this, properly, so you got the right variables.
I guess I have a question, like when we're talking about some of the variables that we're pulling and we're looking at the inter-rater reliability for our abstractors, there's some data points where they're sort of trying to interpret information or interpret an image or things like that, and we're looking at their ability to kind of get the same interpretation. But then there's also data points where, the radiology report said no fracture, and they're just pulling out the no fracture. Do we have to separate it out to say that we're looking at these inter-rater reliability from pulling these objective items for accuracy of transcoding the data, and then one about interpretation and separate them out?
So what you're essentially asking is if you just accept the reading on an X-ray, is that objective data?
Yeah. So then, at that point, do I need an inter-rater reliability to assess their ability to accurately pull that data if we're manually pulling data and it's not in the electronic pool.
If you're manually, then yes, even if they seem rather objective, because they can still make mistakes and pull the wrong thing from the wrong place. And typically when you run your inter-rater measurement, and please correct me if I'm wrong, you run it on like the whole chart. So you would be comparing chart A to chart B, the whole thing, not like the objective versus subjective data points. Now you may preference what you're comparing. Like if you have more important data points, you might say like, definitely make sure that, you know, the outcomes are reported in the same way. But yes, even if they seem rather like straightforward and objective, you would still want to do that.
For 5 seconds, the quick rule of this is the code book is for subjective, the inter-rater is for objective. So your code book should resolve the subjectivity, so you're only using inter-rater for objective data.
Questions about reliability. So for most of these retrospective studies, we are not looking at a single variable. We're looking at maybe 100 or even more. How do we calculate reliability for each of them? And how do we report? The second question is, what is the magic number? What if I come up with something like, hey, I have 0.85. Would you accept my paper because of this? Do I have to redo the thing? Is there any magic, threshold for us to handle?
I think there are two answers to your questions. The first answer is you have to report it so that everybody reading that study knows that, you had moderately good inter-rater reliability. It wasn't great, it wasn't perfect, but it was moderately good. The other answer to the question is when you first have your two different observers reviewing the charts and then you calculate the inter-rater reliability, you make a subjective decision whether that's good enough or bad enough. And if it's not good enough for you, and I don't know that there's a magic number, but at some point you have to say, okay, this is not good enough, we need to refine our process. Maybe they need more training, maybe we have to clarify the variables a little bit. We have to do something to try and improve that. And that's something which, if you report it, makes your study much stronger.
There is an empiric answer too, is you can do a sensitivity analysis and see exactly how, so if you get 0.85, then you can do a sensitivity analysis and say, okay, if this carries through for my whole sample, and I change all these outcomes to be, one that goes against my hypothesis, essentially, like favors towards a null, for example, would typically be the case. Do I get the same result still, right? And if it changes the result wildly, then that's concerning, right? And then that suggests you have to go back to the drawing board. If it doesn't, then guess what? You can stop there and just say, hey, yes, I didn't have the best reliability, but it wouldn't influence my result, my conclusion.
Yeah, I think the bottom line is better is better, higher journal impact, and then you can target unfortunately higher impact journals.
Okay, so there may be more questions. We're here if people have them. Since it's 5:30, we're going to wrap up so that people that need to leave can. But if you want to stay and have questions, certainly we're here. And if you have any feedback for us, please let us know.
Yeah, we don't have the QR code for you to evaluate our session for reasons that we're not clear about. But if you can do it through the app, please, we appreciate your feedback. Thanks for coming.